All right, what's the degree of each polynomial? What we're looking for when we do these problems is we're looking to um, sum up the exponents. If there's more than one variable, there will be more than one exponent, and so we add them together to find the degree. Since this first one has m to the sixth and n to the fifth, 6 and 5 add to 11, and so we have 11 as our polynomial degree. Okay, I call it a polynomial. Monomials, binomials, trinomials, they're all forms of polynomials. Okay, so let's do the next one. We've got a 6 there and a 3 there. 6 plus 3 adds together to 9. So this one has degree of 9. This next one only has a single variable on it, and so that exponent on that variable is the degree, so this has a degree of 7. And of course, if it is a constant and it's not 0, then we say that it has degree 0. You can think of it like this. This negative 9 could just as easily be written as negative 9 x to the 0. Because what is x to the 0? X to the 0, just like anything to the 0 power, is 1. So negative 9 times 1, negative 9. So it stays equal to what it is, and you can see that there's a 0 exponent if there is a variable there. Okay? The one little caveat to all of this is that negative 9 is a constant, and it has a degree of 0. But 0 is also a constant, but they don't say that this has a degree of 0. Okay? This says this has no degree. Okay? A degree of 0 is a degree. It has a number. The number is 0. This 0 itself does not have a degree. So just something to know. But that's how you do it.